In the earlier session, we have discussed about the continental drift theory propounded by 𝗪𝗏𝗏 𝗏𝗏, which explained the formation of continents and ocean. The theory was invalidated based on certain reasons. The post-drift studies revived the concept of drifting of the continents in the form of plate tectonics theory. Plate tectonics theory is the modified, advanced and scientific version of the theory of continental drift. Among the post-drift studies, the concept of sea floor spreading is convincing evidence about the continental drift, and the basis of plate tectonics lies in the concept of sea floor spreading. The main objective of this lesson is to understand the significance of sea floor spreading as a basis of plate tectonic theory. To understand the concept of lithospheric plates and plate tectonics, to understand the concept of plate boundaries and their tectonic significance. The plate tectonics theory was developed during the early 1960s, when the new technological advancement permitted scientists to map the topography of the ocean floor and study the magnetic and seismic characteristics. The term plate tectonics was first used by Tuzo Wilson in 1965, but the theory of plate tectonics was first published by W.J. Morgan in 1967. The theory of plate tectonics is based on the concept of sea floor spreading, advocated by Harry H. Hess and confirmed by Wine and Matthews. Mackenzie and Parker discussed in detail the mechanism of plate motions on the basis of Euler's geometrical theorem in 1967. They postulated a paving stone hypothesis wherein the oceanic crust was considered to be newly formed at the mid-oceanic ridges and destroyed at the trenches. W.J. Morgan and Lee Pichon elaborated various aspects of plate tectonics in 1968. Harry Hess postulated the concept of plate tectonics in support of continental drift. Plate tectonics theory is based on the evidences of 1. Sea floor spreading and 2. Paleomagnetism. In the continental drift theory, 𝗪𝗏𝗏 𝗏𝗏 collected most of the evidences from the continental areas in the form of flora, fauna, fossils, etc. The information collected from the ocean floor mostly provided new dimension for the study of distribution of continents and oceans in the form of theory related to sea floor spreading. The post-drift studies, since the advent of the concept of sea floor spreading, the interest in the problem of distribution of oceans and continents revived. Sea floor spreading has brought new angle to the problem of distribution of continents and oceans. Post-drift studies, which provided the information, was not available at the time of Wegener when he propounded the concept of continental drift. Based on the mapping of ocean floor and paleomagnetic studies of rocks from the oceanic regions, Harry Hess gave the concept of sea floor spreading. The hypothesis of sea floor spreading is a new development which proves the theory of continental drift. Harry Hess in 1960 proposed that ocean floor was mobile and hot magma rises up from the Earth's mantle by the convection currents along the mid-oceanic ridges. and moves away on either side and finally get lost in the ocean trenches situated along the continental coast. In other words, the mid-oceanic ridges were situated on the rising thermal convection currents coming up from the mantle. It is through this process of spreading that the ocean floor has been built. The ocean crust moves in opposite direction from the mid-oceanic ridges, and thus there is a continuous upwelling of the new molten material along the mid-oceanic ridges. The crustal material constantly being regenerated at the mid-oceanic ridges and subject to continuous lateral spreading until it is destroyed in the trenches and becomes incorporated into the mantle. It is thus seen that the ocean floor is relatively young feature on the Earth's surface. Even though the continents are old and apparently permanent features, they drift apart passively and together on the back of mantle generated convection currents. These facts prove that the continents and ocean basins are in constant motion. The concept of seafloor spreading is increasingly convincing evidence about the continental drift. The hypothesis of seafloor spreading has now developed into a more sophisticated and comprehensive theory of plate tectonics. The theory of plate tectonics is an improvement over the Wegener's theory of continental drift and has been considered as the most scientific and comprehensive theory about the drifting of the continents. Some of the basic assumptions of the theory of plate tectonics are: 1. The Earth's crust is fragmented into number of plates. These plates horizontally move over the asthenosphere as rigid units. New oceanic crust continuously generated along the mid-oceanic ridges due to sea floor spreading and destroyed in the trenches. The area of the Earth's surface is fixed, that is, the area of the crust destroyed almost equals to the area of new crust generated. The term plate, rigid lithospheric slabs or rigid solid crustal layer. Lithospheric plates are massive, irregularly shaped slab generally composed of both continental and oceanic crust. Some plates are mostly made up of continental crust, whereas some plates are exclusively oceanic crust. A plate may be referred to as the continental plate or oceanic plate depending on which of the two occupy a larger part of the plate. Pacific plate is mostly an oceanic plate, whereas the Eurasian plate is largely a continental plate. These plates are 100 to 150 kilometers thick and have flexural rigidity and are unable to deform except in response to very strong or prolonged forces. Plate ranges in size from 10 to the power of 4 square kilometer to 10 to the power of 8 square kilometers. Almost all the tectonic activity occurs along the plate boundaries. The thickness of the oceanic plate is less as compared to the continental plate. These plates are continuously in motion both with respect to each other along the Earth's axis of rotation. The term tectonics is from the Greek word tektonikos, meaning building or construction. Tectonics refers to the deformation of the earth crust as a result of internal forces, which can form various features in the lithosphere. Tectonics processes include upwelling of the magma, plate movement, subduction of the earth crust, folding and faulting and fracturing and wrapping of the earth's crust. Earthquakes and volcanic activity. Plate tectonics refers to the whole mechanism of the evolution of nature and motion of the plates. In other words, the whole process of plate motion is referred to as plate tectonics. Plate tectonics is a theory of global dynamics in which the lithosphere is believed to be broken into series or separate plates that moves in response to the convection in the upper mantle. The lithosphere is compartmentalized into 7 major plates and 20 minor plates. Individual plates are not permanent features. They are in constant motion and continually change in size and shape. Plate can change their shape and size by splitting along new lines or by welding themselves to another plate. Most of the major plates are named after the continents, but the plate boundaries do not coincide with the continental boundaries. The major plates are North American plate. This plate is partly continental and partly oceanic. This plate includes North America and Western Atlantic floor. South American plate. This plate also is partly made up of continental and oceanic crust. It covers South America and Western Atlantic floor. Eurasian plate. The plate includes Europe and Asia, excluding India. The plate is mostly a continental plate. African plate. This plate is also made up of both continental and oceanic material. It includes the continent of Africa and Eastern Atlantic floor. Indo-Australian plate. This plate contains India and Australia and western part of Indian Ocean. This plate also is made up of continental and oceanic crust. Antarctic plate. This plate is similar to Indo-Australian plate, that is partly oceanic and partly continental in nature. It covers the continent of Antarctica and surrounding ocean. Pacific plate. It is completely or purely an oceanic plate. It is one of the largest plate covering the entire Pacific Ocean. The Pacific plate is the largest plate composed of almost entirely oceanic crust and covers about 1/5 of the entire Earth's surface. Some important minor or intermediate plates are Nazca plates, Coco plate, Arabian plate, Philippines plate, Fiji plate, Caroline plate, Caribbean plate, Scotia plate, etc. The Cocos plate is located between Central America and Pacific plate. Nazca plate lies between South America and Pacific plate. The Arabian plate mostly includes Saudi Arabian landmass. Philippines plate is located between Eurasian and Pacific plate. Caroline plate lies between Philippines and Indian plate. Fiji plate is located to the northeast of Australia. These plates are moving over a viscous material below the lithosphere called as asthenosphere. Moreover, it may be noted that all the plates throughout the exception have moved in the geological past and shall continue to move in the future as well. A plate boundary is a surface zone of motion between two plates. A plate margin is the marginal part of the plate. Tectonically, plate boundaries or plate margins are most important because all the tectonic activities occur along the plate margins, like seismic events, volcanicity, mountain building, faulting, etc. Young fold mountains ridges trenches, faults surround the major plate boundaries. There are three types of plate boundaries. 1. The divergent plate boundary. 2. The convergent plate boundary. And 3rd, conservative plate boundaries. Divergent plate margin is also called as constructive plate margins or accreting plate boundaries. Divergent plate boundaries are also called as constructive plate boundaries because along the plate margins of the divergent plate, new crust is generated as the plate moves apart. The sides where the plates move away from each other is also called as zone of spreading or spreading sides or source. The sides where the plates are pulled away from each other resulting in seafloor spreading. Hot molten material from the interior of the earth, that is lava, spreads along the divergent plate margins. Thus, a new crust is continuously formed along the margins of the divergent plate. New crustal material from the asthenosphere is added along the zone of spreading. The molten lava cools down and solidifies along the trailing end of the divergent plates. When the spreading site opens within the ocean, the hot molten material spreads along the divergent plate boundaries, that is seafloor spreading, giving rise to the formation of mid-oceanic ridges. For example, Mid-Atlantic Ridge, which is located in the mid of the Atlantic Ocean, extending in a north-south direction. The best known example of divergent boundaries is Mid-Atlantic Ridge, along which the American plates are separated from the Eurasian and African plates. When the spreading center opens within the continent, it gives rise to the formation of linear deep in the form of a rift valley. Faulting volcanoes and earthquakes are very common here. For example, East African Rift Valley, Red Sea, Gulf of California. Such plate margins are also called as destructive plate boundaries, sink or zone of compression. Along the convergent plate boundaries, two plates will collide and strikes against each other. Therefore, such boundaries are also called as collisional plate boundaries. When the plates strikes each other at a very slow rate, the resultant tectonic activity will be in the form of a gentle buckling or folding of the earth crust, that is formation of fold mountains and earthquakes. When plates with differences in density meet in opposite direction and collide, the denser plate plunges or dives under the less dense plate. The zone along which one plate plunges or sinks below the another is called as subduction zone. It is the location where sinking of the plates occurs. Subduction zones are the areas where plate material is destroyed. The important subduction zones are Himalayas, Java Trench along the western margins of North and South America and Africa, West Asia, Philippines coast, etc. There are three types of plate conversion: ocean continental plate convergence, oceanic plate conversion, and third, continental plate conversion. When one continental and another oceanic plate collide, the oceanic plate, being denser, goes below the continental plate. Collision of oceanic and continental plate is marked by earthquakes and the formation of trenches in the ocean. When two oceanic plates collide with each other, the relatively denser oceanic plate moves below the lighter oceanic plate. When one oceanic plate plunges below the other oceanic plate, it results in the formation of deep trenches in the oceans and also the formation of volcanic islands and island arcs such as Tonga, Hawaiian and Aleutian Islands. Many island arcs of Western and Northern Pacific Ocean resulted from the convergence of two oceanic plates. When two continental plates moves towards each other, the continental plate having relatively more denser material moves below or subducted under the another continental plate with relatively lighter material. The resultant lateral compression squeezes and folds sediments on the either sides of the continental plate margins. The convergence of two predominantly continental plates result in an orogenic belt, that is mountain ranges. When two continental plates converge along a line, then fold mountains are formed. For example, when Indian plate and the Eurasian plate collided, the sediments in the Tethys Sea were folded to form Himalayas. Alp mountains in Europe resulted from the convergence of African and European plate. Conservative plate boundaries are also called as neutral or shear plate margins. Conservative plate boundaries are characterized by transform faults. Along the conservative plate margins, the movement of the plates is parallel. San Andreas fault formed due to the parallel movement of Pacific and the North American plate. Usually, there is no volcanic eruption along the conservative plate boundaries, but seismicity or earthquakes are common. Transform faults are located perpendicular to the mid-oceanic ridges. The movement of the plate is parallel or lateral. Transform faults are to be found to transect or offset the mid-oceanic ridges. The transform faults link plate generation area, that is mid-oceanic ridges, with plate destruction area such as trenches. Transform faults are roughly located parallel to the direction of plate movement. Transform faults connect convergent and divergent plate boundaries. Various combination ridge-ridge transform fault, ridge-trench transform fault and trench-trench transform faults. Transform faults are so called because the kind of motion between the plates is changed or transformed at the ends of the active parts of the fault. For example, diverging plate motion between two plates at an oceanic ridge can be transformed along the fault to the converging motion between the plates at the subduction zone. Triple junction are points where three plates meet. The plates will converge or diverge or move parallel to each other, but the only way they can end is in the form of triple junction. Such junctions are necessary consequence of rigid plates on the sphere, since this is the only way a plate boundary can end. There are many possible combinations of ridge, trench and transform faults, triple junctions of which 6 are common. For example, the triple junction of Eurasian, Pacific and Philippine plates is the combination of trench, trench, trench combination. Nazca, Pacific and Antarctic plates is a combination of ridge and transform fault. American, Pacific and Juan de Fuca plates is the combination of ridge and transform fault. American, Caribbean and Cocos Plate is the combination of trench and transform fault. Pacific and Antarctic and Nazca Plates is the combination of ridge to ridge. Eurasian, Austro-Indian and Arabian Plates is the combination of trench and transform fault. Plate tectonic theory is the post-drift theory which revived the continental drift theory. Plate tectonic theory is based on the studies related to ocean floor, like sea floor spreading. In the continental drift theory, it is assumed that it is the continents which were drifting. But the theory of plate tectonics introduced the concept of plate, which is the part of the lithosphere or the Earth's crust, constituting both continental as well as oceanic crust. The lithosphere or the Earth's crust is compartmentalized into 7 major plates and about 20 minor plates. These plates are moving over the ionosphere. The concept of plate boundaries is discussed in length in this session because all the tectonic activities like folding, faulting, volcanism and seismicity is associated with the plate margins. 3 types of plate boundaries are identified and the associated tectonic activity and its movement are discussed in detail in this session. In the next session, the driving force for the movement of the plates, the contribution of this theory towards understanding of the mechanism of fold mountains, volcanism and seismicity will be taken up.